Hello and welcome back to day 2 of API Days Paris, but we all know what that means where we are. We're all in our home, and I'm so grateful you're joining me from your home or wherever you're joining today. One of the benefits, one of the losses of having these events online is food, because honestly, England in general, not the greatest for food, but really good food for events. So I'm excited to have taken this break to actually take a break and make myself a nice lunch that I'll tweet out later. That's in the oven right now, to have like a nice little posher lunch that I would normally have at home on a rush, because we need to take some self-care. So add in the chat, please, what you're eating for lunch or breakfast or dinner or whatever you're doing to make yourself feel a bit better. Give yourself a bit of self-care today. Make sure to take those breaks. These are being recorded. You can always come back later. You don't need your FOMO. So now we are moving on to the API lifecycle management track. It should be very interesting. And I'm really proud to bring Priya to the stage, because I think it's just a topic we haven't talked about as much about from a networking engineer perspective. So Priya, are you sharing this geared towards a network engineering audience, or for others to also understand and create empathy for the network engineers that are often maybe not in the mix of API design?
Yeah, I think it would be a mix of both. Basically for network and security audience, but even others will benefit knowing about these topics.
I mean, certainly for security. Why don't we go ahead and share your screen and make sure everything's going okay? Sure. That looks great, and I'll catch you on the flip side.
Sure. So hi everyone, this is Priya Saxena, and you can see from the title, I'm a network engineer, and I work for Google Cloud, and I'm also a regional lead for the Europe practice area. So today I'm going to share with you some of my experiences. And again, this is not going to be limited to Google Cloud, of course, because I work in this company. I work with customers on these products, and mainly API management product for us is Apigee, you might be familiar with. So I'll be giving examples on my learnings with Google Cloud, with Apigee, but definitely you can use it with your own products or any other cloud provider, wherever you feel like it fits in. So I'm here to talk about not specifically the product, but the idea, the concepts, the security layers we feel like we should have in place. And feel free to ask me questions and reach out on the chat later on. So like I said, this is not going to be like an API kind of session. This is more of what beyond API. Of course, API management is the core concept. API days, we all come here to learn about APIs, which I'm sure you'll be learning in other sessions as well. Now, here, I really want you to take a step back and think of what other things play in the ecosystem other than the API itself. So for instance, if I take example of the product I work with, Apigee API management, if I imagine that as the central block, I'm going to touch base on all the other things which are around it, which makes it, reachable, secure, faster, performance efficient. And we'll touch base on some of the data analytics side as well to it, so that you get overall, 360 degrees view of what else is being done, because what technology is moving very fast and we can't separate out one domain from another. So again, being a network engineer, I never thought I'll enter the API management domain, but I did, and I'm really liking it. I do design proxies, policies. So I do work in the API management space, but the more you know about the areas overlapping with it, the more, the more it is better to design a network. So, like I said, we'll discuss about the network aspect to it, and mainly the security aspect. Now, again, all the API management products, most of them, they do cover security at an API level. How to secure your APIs. Now, we'll discuss about what other than just the API product itself, what other security layers can you have, and as security experts say, the more layers you have of security, the better it is. So of course, APIs should be secure. You should have all the mutual TLS, all the other policies there. But it's even more better to add on different layers other than just relying on the API security itself. Same way, we'll also touch base just for some time about the AI related aspects of how in Google Cloud, what kind of features are available. And again, like I said, you can relate it to your own product and provider and maybe see what is an alternative in other providers for this similar concept. We'll also touch base on multi-cloud because this is becoming more and more important. So I'll say an example. For example, I have my internet provider. I really want a choice. I don't want to be stuck with one provider all whole my life. So I really want to have a choice of shifting, checking out what's if it is one provider, moving to another one, trying out other things. Same way, cloud has become like that nowadays. Nobody wants to be logged into one vendor or one product specifically. So customers they prefer having something like multi-cloud. And with Google Cloud, we have launched certain products like Anthos, and even Epig is one of the areas where customers are preferring that. Let's try with, if they have more than two cloud providers, let's try to reach out with AWS, with Azure, with Google Cloud, have a mix of more than one. So Epig has, with the new product of Epig, we have released certain multi-cloud features which are interesting as well. I'll give you some pointers at the end of the session. You can go and 20 minutes is not enough to satisfy any of these domains, very honestly. So you can go and read more about it and get in touch with me on LinkedIn, or I'll give you my Twitter ID as well. So other than that, performance and reliability, they always come in, because most of the time, like, I work mainly with financial customers, with banking customers. And API management, for me, the bank or financial institute, whoever it is, if they are having a customer facing portal or something, then reliability is the main thing. Nobody likes seeing a error message, 404 not found or service not available. So reliability is one main thing, and performance. If you trigger a request, it comes back after 1 second, 2 seconds, it's no good. So we'll touch base on what are each of these, how are they playing a role in your API management solution on the whole. So yeah, coming to the first and foremost, security. And honestly, wherever I go, my first session, second session, questions are all about security. What is it that, because I go with a design and architecture perspective. So I'm one of the SMEs who will suggest what is preferred, what is possible, what is best practice. And security is always a major part of my discussions with the customers. So with Google Cloud, we propose certain, like I said, not just one shot security solution. We like layers of security, as many as possible, the more the better. So few of the first entry points. So when you have your customer facing, think of it as a mobile phone, some mobile application. You want to access your API backend wherever it is. Now, from the mobile application, now one of the first boundaries is when it enters your network, before even it reaches your API software itself. For example, Epig. Before it reaches Epig, we try to provision layers to address these security issues. The first one comes as the cloud armor, which is at the edge of the network. Now, because it is an internet request, especially for an internet request, it's coming from an untrusted zone. So for that reason, we say that better have a web application firewall like a cloud armor. And again, Google Cloud, even networking itself, the software stack in Google Cloud, that has DDoS protection built in. But cloud armor is one of the main, we can say, weapons to shield ourselves from that intrusion attacks and all. So we prefer having a layer of cloud armor first. Again, you can have an equivalent in other providers as well. Second thing would be cloud identity and access management. So with this particular thing, we say that only certain users who are authorized to access that thing should be able to access. So this comes with a variety of roles, with a variety of, like, even if for Epig API management, if you have multiple teams, you don't want one team to look at the code from the other team. So you do want these IAM level roles saying they should have access, but only to this particular resource. They shouldn't have access to the other one. So there comes the second layer. And then another one which we really emphasize customers is VPCSC security controls. Now, this is mainly for data exfiltration. So what happens is, sometimes even though we have internal users, unintentionally data can be transferred by its human error. People can transfer it by mistake, send it across somewhere. So this VPCSC perimeter builds up that kind of ring around your critical resources, that nothing can be copied or sent out even by mistake, even by internal employees. So that's one of the major reasons we always emphasize that secure your API management solution, so that only the resources which are needed to access, those are the only ones which have access to certain data. So it basically avoids the exfiltration path. Recapture, again, these are bot algorithms, risk based, and for fraud detection. So I would really say, if you are designing your API management solution, go and check out this particular, you will find it in Google Cloud web pages. So fraud detection and all, based on machine learning, what has happened in the past, what was the pattern, how was this particular attack committed, it tracks that and it makes sure that it's not done again. So have a look at that. And cloud DLP, again, this is really important for us, because many times, like I say, banking and financial institutions, a lot of sensitive data. Although, some people, many times it's a myth that cloud is not secure, we can't send it across. I would say, if it is secured in a good way, in a better design, then it is secure enough. So we have a lot of these cloud DLP can be used for masking sensitive data, or removing the identifiable information. So, and especially with Europe, we have GDPR and all these compliances. So most of the institutes prefer having these products in play. And CMAC, finally, encryption keys. So this is more of a customer satisfaction, that even the keys used for encrypting are customer managed. So customer can specify their own keys, they can manage the keys as well. So, like I said, multiple layers of security is always better to have. And then comes the part where I said I will touch base on AI. Now we are investing heavily into making AI as one of the features in most of our product areas. And with this one, I would say, with Epig specifically, it is capable of identifying anomalies, then predicting traffic. That's again one thing. Black Friday, the servers are offloaded because it's really high peak traffic. Now these algorithms, if they are in place, they'll look at what happened last time, and if we need to scale it up, just scale it up before that event happens. So instead of getting into a huge traffic overloaded servers, it's automatically scaling the infrastructure before that thing happens. So, and again, even for compliance reasons, APIs should adhere to that. So these are some of the features which we again ask the customer to use it if they are worried about these things. Then comes global reach and performance and reliability. Now, with this, specifically with Google Cloud, again, I can talk about this product. I'm not really sure about others. So, with Google, we have 24 regions where Google Cloud is currently available, and it's every day. It will be changing every day, and there are caching on in more than 100 locations. So, this makes it very easy to cache it to the nearest location, and performance will be impacted. It will really huge. It will have a huge impact on performance. And even storage wise, the choice of where customer wants to store, because certain countries have some limitations that the data shouldn't go out of the geographic location. So in these cases, there's a good choice in your hand to see which area you prefer the data analytics to be stored, or if you want. And again, there is a another product as well. So one is what is SaaS, the fully managed. The other one, we call it as Epig hybrid, which is again, its main workloads are on your premise. You can deploy it, so it doesn't, the API traffic doesn't go to cloud. In that case, it goes to your own on premise infrastructure, wherever you want. So some customers who are really worried about performance, or storing data elsewhere, then for those reasons, if you have those compliance issues, we have another variant of the product, which is more of a hybrid product. So hybrid architecture is, like I said, the last point is, it is used for mainly low latency. If you want your backends to be very close to your processing time, the Epig runtime itself, then that's the way to go with it. And multi-cloud, a lot of interest is coming up in multi-cloud. Say if you have your backends, or you want your data to be in a different cloud provider zone, even that can be connected using either on-premise or separate cloud provider. So these are all the variations possible if that's your requirement. So coming to one of the sample architecture. So I would say that on the pink side, if you see, this is where I'm representing Epig runtime. Now this is where your actual processing of the APIs will happen. And this example I'm giving for a fully managed service, not the hybrid, but the SaaS version of it, fully managed. So what we say is Epig X runtime. If it is on this side, then we have a total fully isolated network. Now the customer network, and green side, if you see, that is where your customer is coming from, say mobile phone user. So if they are trying to access your APIs, they go through the Google Cloud project and then into the Epig API management. And on right side, you find your backend data, where your actual, where your After processing the API, it will enter the target servers. So for this one, if you see, it's totally isolated so that this particular APG instance is not exposed to a public IP. And that is one of the main security wins. The more we have if it is directly exposed, there's more chance of getting intruders attacking, all these things happen. But if you don't have a public IP, then there itself you're cutting it from the wild internet. Now this is the project which I'll talk about, where I've been summarizing all those things play a picture, like armor, VPCSC, all these. Now what we prefer is internal to the runtime, and again, as I said, the backend is on the other side of it. So internal to the runtime, before that, we say that okay, we want to expose it only through a peered network. There is a concept in Google Cloud called network peering. Now this enables this network to talk to the resources on APGX runtime project. So there is a VPC peering, and let's assume it's in one region right now, that we do. And then what we see is the peering will access it internally, so no one from outside can actually access your API management instances directly. And then we try to make this one have as many security layers as possible. Like for instance, here in our diagram we have this L7XLB, which is a global load balancer. Now it is regionally, it can balance between multiple regions. If you have a Belgium data center, or say something in London, then it automatically can flip in case of disaster recovery. And then along with this, you can have something like a cloud armor, which is again that first layer of defense which I spoke about internally. So the request, the API request comes in here, it goes into your network bridge, which is like a bridge between the two ends, between APG and the front end. Again, you can do some mutual TLS termination here, whatever other requirements you have. And finally it enters the API management and then goes back to the backend and then back to the user that way. Now here the thing to notice is that yes, this is exposing the public IP, the global load balancer. So any kind of attack will be here, not on your actual API management system. So this one is well capable of handling all these intrusions and all. And again, when you associate it with cloud armor, with other policies, this is much more secure to act as your first layer of defense. Plus it has this regional multi-regional global presence, so any region, a region getting down, it's easy to flip it to the next traffic to the next region. And then for internal workloads, we say you don't need so many levels of security because it's an internal traffic. Then it can go directly to the runtime. So this will again be bypassing those hops, multiple hops. So now traffic privately, again private traffic goes through this, public facing goes through those many layers of security which we added. Other than that, I didn't show about VPCSC perimeter here, but you can club your resources in that ring of VPCSC, wherein even data exfiltration is avoided. If even unintentional access, somebody by mistake doing it, those things are checked. So in a nutshell, a typical architecture life cycle for API management, I would say, from your internet facing connection, go through the Google project or even other providers, whichever you are preferring. Have your load balancers, have your cloud armor, have your WAF security, or whatever other products you might want to use. I will not name any, but you have many more WAF products. You can set them up here. Then go to an intermittent VM or a bridge, which is used mainly for another layer of security, maybe terminating your MTLS or having your certificates, whatever you want to prefer it for. Then your API request goes into your API management system. And then here I'm depicting APGX of how it does. It's again having an internal load balancer. Here your processing happens, your API is actually processed, headers are passed, whatever policies you want to impose. Then from the NAT part, it goes back to your backend. And then all the way back, it goes to the customer, the reply back. So this is a typical setup, which would, again, depending on different compliance rules, what are the security requirements you have. We have many more patterns which we will be publishing on the Google Cloud pages going forward. This is just the beginning, so we have published, this is available on the Google Cloud blog site. But there are 60 to 70 patterns, really, depending on different requirements customers come up with. We'll be slowly publishing mostly used patterns. Right now they are internal to our organization, but we'll publish it so that you can pick up which one and all the pros and cons of each of these methods. I think with that, I'll just highlight one more thing. For all these patterns, My team is also working on automating it. So we are developing Terraform modules, which will be, you like this pattern, just use this script and done. It is deployed there. So it will be like a really good, quick way of deploying your instance. Again, this is all to do with APGX, and you can go through the link I have highlighted here, and you'll get a readily deployable pattern for that particular, whatever you prefer as the choice. So with that, I think I'm out of time and I'm open for questions now.
No, that was really helpful, Priya. I think there's a lot of valuable information in that. And like you said, there's patterns which aren't vendor exclusive at all, and patterns of behavior. So, what are the questions that a network engineer should be asking about security? What are the priorities? What would be like a big red herring that like they should really be looking into that maybe they're missing?
Yeah, I think there's not like one single thing, but definitely the most frequently asked one for me would be DDoS protection, mutual TLS, if that is there. And also, many times we feel that while designing itself, you need to keep yourself aware. What is the disaster recovery plan? Do you want it multi-regional? Do you want it on-premise? Is latency a problem? Is If that is the thing, think of a product which is like APG hybrid, which can be deployed on-premise, or if you want multi-cloud. So I would say networking-wise, disaster recovery, security, and even this deployment either in the cloud or on premise based on the latency requirements, that would be important.
And yes, you said latency requirements, but are there questions about environmental impact requirements? Is that just nascent and not being talked about yet? Because obviously networking engineers would be the gatekeepers if they wanted to be for people over, not just overexposing themselves to more security issues, but to more, environmental issues.
I haven't got many questions on that side, to be honest. But and again, I think that depends on the way data centers are maintained. Environmental issues are, again, Google Cloud maintains a lot of this reusable resources. So that's a strategic decision. I would say it's not like a network engineer's level of discussion. But yeah, definitely you can, to be environment friendly, just choose a cloud or choose some product which is more relying towards reusing these energy things. So, but yeah, not specifically for network engineer, I would say.
Okay, it hasn't come up yet, but hopefully it will, because everyone has to be part of that discussion. That's great. We do have a question from the audience, which is how will the on-prem services contacted, but I think they mean connected, over internet or with co-location private channel?
Yes. So in case if I get it right, then you want to connect your on-premise to your resources in the cloud. Generally, that's what is seen in enterprises, that they prefer dedicated interconnects, which is again dedicated for your company, fast throughput, everything, or partner interconnect. Very few times I really notice a VPN-based connectivity, but usually dedicated or private interconnect are what is preferred. But VPN is
Okay.
also good enough. People can use that.
Okay, great. Thank you. We have another question. Aren't network bridge VMs not highly available, and their network throughput is limited as well, decreasing the high availability and the performance of the whole scheme? Okay, they added a question at the end, but it was more of a statement for you to validate or not.
I think again, with the VM network bridges, you can choose what kind of processor you need. It can go up till really high processing VMs, and again, that is just an intermittent solution for now. In the future, you will not need network bridge VMs. It will be able to contact directly. I would say in the future, in the sense coming few quarters, I will say network bridges will go away. Today, we will need them, but again, you can use really high performing VMs. I haven't seen a problem with that in even customers on Black Fridays. I haven't seen a problem with throughput and all. You can just pick up what suits your prod requirement based on that.
That's very important. Thank you so much, Priya. I think your talk brought into this overall theme we're seeing in the both API design and lifecycle management, that you need empathy and to talk to more people across your company to learn from each other.
Thank you so much. Thanks for having me.
And thanks